So today's objective for the talk regarding sleep regularity is to answer these questions. Why has sleep regularity gained so much scientific and clinical attention in recent years? Why does sleep regularity matter for health? And what biological mechanisms might explain its relevance? And which sleep regularity metric should researchers use and under what circumstances? And what are the strengths and limitations for each? And how can sleep regularity be measured using wearable data, particularly consumer wearable data, which is going to be the focus for Labyrinth particularly? And I've divided sleep regularity into six categories here. The first one is Intro to Sleep Regularity. I will talk about clinical significance of sleep regularity, the physiological mechanisms, associated factors, the metrics, and also future directions as well. And so traditionally, the focus for sleep clinical care has been on sleep duration. And this is a result of well described relationships between sleep duration and key clinical outcomes. This meta analysis done by Yin in 2017 shows that U shape or J shape relationship between sleep duration and a number of key clinical outcomes, all cause mortality, total cardiovascular disease events, coronary heart disease events, and stroke events. And you can see that there's a sweet spot about 7 to 8 hours where you have the lowest incidence of mortality or these adverse events. And then if you slept a little too little or too much, that could be bad. This relationship at present appears to be correlational. It's unclear if it's causal because it could be that those individuals who have some predisposing conditions can actually sleep more or sleep less. So it's unclear whether it's causal or correlational. But as a result of this emphasis on the sleep duration being important for these various key clinical outcomes, public health has placed most of their energy on optimizing sleep duration. For instance, this is the American Heart Association's Life's Essential Eight. And you can see it outlined here: eating be it better, being more active, quitting tobacco, managing your weight, controlling cholesterol, managing blood sugars, and managing your blood pressure, and get healthy sleep. But when they talk about getting healthy sleep, this is the actual depictions that they show on their website. Adults should aim for an average of 7 to 9 hours. And obviously, it depends on the age. But we have recognized that sleep is a multidimensional construct, which, as proposed by Dr. Dan Bicey at University of Pittsburgh, which not only includes sleep duration, but also sleep efficiency, like how effectively one sleeps, often incorporating information on sleep stages. We're interested in sleep timing, the chronological aspects of when sleep occurs, and you might incorporate circadian rhythm within this category too. Then there's sleep regularity, and then sleep satisfaction, the subjective measures of how restorative sleep feels to the individual, and daytime alertness, another qualitative measure assessing cognitive function during the waking hours. And so the question is, what is sleep regularity? And basically, it's just the consistency of sleep wake patterns from one day to the next. And this is depicted using a raster plot. And raster plot just visualizes the time that you're asleep from day to day. And this is obviously an idealized version, a high sleep regularity where the person sleeps exactly the same time and then wakes up at the same time. A low sleep regularity, you can imagine, has a lot of variability in the timing of when a person goes to sleep, what time they wake up, and there could be fragmentation too. A lot of times when they're awake in the middle of the night. And this sleep regularity topic has really become a hot topic. And if you've gone to any of the sleep research meetings, there's a buzz about it, especially in the last few years. And there's a number of reasons why. And the first one is that there was an SRI, or the Sleep Regularity Index, which was developed by Dr. Andrew Phillips during his time at Brigham and Women's and Harvard Medical School and published in 2017. And this exact same SRI index was subsequently incorporated into large epidemiological studies, such as the MESA, or the multi-ethnic study of atherosclerosis, and published in 2018. That study showed that irregular sleep patterns, as documented by this SRI index, was associated with increased cardiometabolic risk factors such as obesity, hypertension, fasting glucose levels, and hemoglobin A1C. Then the big study that got a lot of press was the one published by the Phillips Group. Dan Windred is the first author. They incorporated the SRI index in the UK biobank, and that showed that sleep regularity was actually a stronger predictor of all-cause mortality than sleep duration. And then there are some follow-up studies just this year, again using the SRI index done by Andrew Phillips, and again applying to UK Biobank, but this time focusing on dementia incidence. And it showed that sleep irregularity had a dose response correlation with dementia incidence. And all of this received a decent amount of attention in the news. And also, the National Sleep Foundation put out the consensus statement to 2023, which we'll talk about later, which truly emphasized the importance of sleep regularity. The other additional component for why sleep regularity has become popularized is because it's actually become much more accessible. And that has to do a little bit with the wearables that are enabling this. And this is actually the data that we generate through our LabFront app and incorporating our Garmin Vivo Smart 5. And this shows a raster plot of an individual over a span of about 4 weeks. You could see the sleep period that are demarcated using our sleep activity methodologies, and you could see the amount of regularity here as well. And there's also availability of open source analytics, such as the GGR package, which is the R package, and the SleepReg package made available by Dan Windred, who did that major publication with the UK Biobank. There's also a Python version of this as well. And so both these things have made sleep regularity increasingly accessible to researchers.